Yeah, so hey everyone. Today's going to be probably like a brief session because I am preparing like another tutorial on graph neural networks. And so what I want to talk about today is this idea of grammar of graphics. So what is this, and why should you care, and what problem is this trying to solve? So typically, like when you're doing any sort of plotting, you may have like used something like Matplotlib, right? And in Matplotlib, you come in and then you say, for example, well, this is the function I'm trying to plot. This is the axes, these are the grids, and then you say something like say figure, and then you plot. However, like let's say you wanted to, for example, change the style of this thing, or you wanted to like superimpose several of these plots next to each other, or let's say you wanted to group this by some other element in the data set. Then it's like not entirely obvious, like what to do next. Like you basically need to go back to the libraries and to the documentation. You need to sort of kind of go through it and find a couple of examples and see, well, like and hope that someone's made the exact kind of visualization that you want to use. So this is great for sort of CAD stuff like time series, but like if you're trying to build complex visualization, this really becomes a hurdle. So what kinds of complex visualizations am I talking about? So really what I'm talking about is like this sort of like visual display of quantitative information that was popularized by people like Edward Tufte. And so here you can see these visualizations are on a whole different scale, right? Like, so here you have like these concentric circles, for example, or here you have all of these lines going from one point to another. And so maybe you can build this with, I mean, yeah, this is on the cover as well. So maybe you can build this with Matplotlib, and I wouldn't be surprised if someone did indeed build a library to do this. But for the most part, it's not available out of the box. So someone else must have built it. Maybe you can, do it by looking at some of the source code and getting inspired off of it. But there's sort of a different approach. So like a plotting library that's really popular in the R community is called Ggplot. So what Ggplot is it's what we call like a grammar of graphics library. And so what you do is, for example, you say, well, like I want to plot like this data set, and then I want to add these points, and then let's say for each of these points I also want to add their mean, and I want to make the mean red, and I want to make the point of size 3. So already this is looking a bit more custom than what we saw before. uh, but for the most part, like yeah, and so there's also like a book about this. It's really really good. It's kind of a dense read actually. It's not just like a visualization book. It's more of also a statistics book. I don't know, life book, object oriented design book, math book. There's a lot of ideas in this book, like psychology. Uh, so it's great. I mean, if you want to go through it, but I don't use R, so I don't want to use R. I don't want to learn R just to do visualizations. But instead, there's this library called Plot9. So Plot9 is a grammar of graphics library in Python. And so here, for example, I'm showing an example where you can just like install it like in a Google Colab notebook. You import a bunch of stuff. And typically, the input to any of these grammar of graphics libraries is going to be a data frame. And a data frame, you can just think of it as something like a CSV file. So here, for example, like we have a bunch of car with their gear, like their miles per gallon, and a bunch of other data. So what can we do with this? So in this grammar of graphics idea, typically you want to compose layers. And so this is very similar. Like, again, if you followed a bunch of my other streams, you know how in Keras, like you would basically say like, you have some sort of model, and then you would say, let's say I'm going to call this, right? And then you would say model.add layer 1, and then model.add layer 2, and then you keep going. And like it's not like you can't like you can do this without this paradigm, but it makes it your life a lot easier to think of it in terms of these layers. So grammar of graphics is very similar, but for visualizations instead. So for example, here what we're saying is, okay, look, we want this data set, and then we want to keep track of these two data points like WT and MPG, and then we want to plot the points. So like let's say just to just show you what I mean. Like let's say we added HP. Let's see what would happen, for example, if this still works. P, it looks like it's just ignoring. This so it looks like geometric point won't work for 3D data. I imagine. Yeah. So let's just do this again. So this is fine for now. Um, so here, for example, like you're saying, okay, well, I want you to take this aesthetic, but I want you to color things by this element in the data. So here, for example, I want to color it by name, for example. But names is like a fairly high dimensional data set. So instead, for example, let's try something like gear because it looks like it's simpler. So if you try gear, then you kind of see like already like this is kind of interesting. Like so this is doing a group by essentially, and then it's doing a color by group by. And we did this without writing any sort of additional code, looking at any sort of crazy libraries or anything. It's just like you just like sort of figure it out like this. Another thing you may want to do is that, well, you want to draw trend lines for each of these factors. And so, for example, here you can say something like stat smooth and then give it a method. Uh, I forget what lm is. Let's just say it's just like some like plot plot a line through it. And so if you plot this by gear, it's gonna plot a line for each of for each of these factors. And so already you can see like this is getting very compositional. And so let me just show you if you remove this, for example, end of line. Yeah, you see. So here, because you're not doing a group by, it's just doing like the sort of smooth plot from here. So let's see. So here, what happens if we don't say the method, for example? I'm curious. Yeah. So you're already seeing, right? Like, so one was you create a blanket as a line, and then the other is you just draw like the straight line. So depending on the kind of data that you're presenting, like you may want to vary this. And I like this because it just doesn't take much effort for you to try different stuff. Another really interesting one is this facet wrap. So with facet wraps, you're basically splitting the data by a certain factor. So like instead of having one plot, you have three separate plots where it's grouped by. So, I mean, let's say you did this, for example, like this is going to be much bigger, just to give you some sense of how powerful this is. Yeah, so it's just like a single point, but you see like how it automatically created this like, very complex chart. Uh, I guess instead, for example, we could say we could say, okay, like let's say, I think gear was good, right? Because it was like just four examples. And another thing is that like a theme also becomes part of a theme is just also this thing that you append. So you could just, for example, say, okay, well, great, I want the XKCD theme. And so if you're doing this for a talk, for example, it just looks more accessible in general when lines are like hand drawn, like people think they're friendlier and it works. I don't know why, but it does. And so this is sort of gives you a high level sense of what's going on, right? So like so the core ideas again are your input is a data frame. Then you like say, okay, well, these are the features I want to take a look at. You can say, okay, I want to do a geometry of points. I want you to smooth the points with some method like a blanket, but there's probably other methods if we look at the docs. Another interesting thing is we can take facets, so we can just take multiple plots of a certain data set, like multiple figures, and subplot it. And we can also append the style. So this is sort of like the Hello World example, but let's cover like a few more. So you can really see how powerful this framework is. So here, for example, I'm going over all of the examples in the gallery. So I'm just going to do like a speed run through them, and we can get some sense of how these work. So here, for example, it's like, well, not only do they have, so here, for example, like in their plotting, okay, let's see here. So we're saying, first off, we're doing this geometric path, right? And then we have these limits for the scales. And then, the theme is this, and we're just like adjusting some sort of aspect ratio. Uh, ORC animations. Let's do animations maybe some other time. So this is similar here. So check this out here. So we're gonna here. So first off, like this is similar to the previous example we saw, right? Where we're saying, okay, well, we want to take geometric points, and then we want to use the labels. You could also say, okay, well, I want to add like a line, and I want this line to have this intercept and this slope from the data set. That's totally valid. You could add multiple of these lines if you give it like arrays. Uh, and then you could say, okay, well, not only do I want to add a line, I want to make it of size 2, and I want it to be dashed, and I want it to be blue, and like it's all good. Like the facet is something we talked about earlier, right? So here they're taking the facets relative to this thing called DRV, and it just all works with like very minimal knowledge of the libraries. So another example here is like I think yeah. So this is like they're calling it a box plot, right? And so let's take a look at these again. So we're looking here. So what's this data set? The whiskers data set. So oh, so basically the passengers and the month they were born, right? So we're doing like a sort of version of the birthday problem, and turns out it looks like most people are born around June, and it also gives you like sort of like percentiles around it, and so that's where box plots are useful. It's like when you're trying to plot some sort of distribution relative to something. Uh, yeah, month passengers. Okay, interesting. And so if you want to make it horizontal, how does this work? Oh, so you just say coordinate flip, for example, right? So a lot of these, like I like to think of them as verbs, like as in you say, okay, I want you to plot this. I want you to plot this like this, and I want you to flip the coordinates. So once you start thinking of plots as verbs, it becomes like a lot more intuitive to start composing them. It's sort of like imagine you had someone who's a domain expert at plotting, and you just like told them in sequences the things they'd like them to do, and then they just go ahead and figure out how to do it. Geometric jitter. So box plots with jittered points. Okay. I guess so. These are some of the points relative to the data. So let's say, I mean, I'm curious. Let's do an example actually here, because I think this will be even more powerful. Let's just do this. So sort of just like show you what I mean when I say like you can build off of this example. So let's say we have this, right? And then we're taking in this flights data set. Okay, so we don't have this flights data set. Uh, so this is just using the head. Where is this flood data set? Yeah, so we just need to make sure to pull this in. So I don't know where this data set. I'm not going to look for it right now. But the idea here is that, well, you could say, well, I want a box plot, and then you could say, well, what I just want the points, for example. And if you compose them, then you can have in the same chart both the points and the box plots, as opposed to in Matplotlib. Like I'm not sure at all how you'd go about doing something like this. So here, for example, like another version is you could say, well, I want to take columns, for example, again, as opposed to points, you would say I want to do columns, and then they're filled by categories. So let's see, so yeah, so we have, oh, I see, like the x variable is just variable. What's variable? Oh, so what's the value here? Okay, so I guess like here when they say variable, there's a lot of stuff, right? There's your gender, there's your age, there's your income. And then when they say value, what's value then? Is it this is just a weird data set to understand. Um, yeah, this data set doesn't make much sense, so let's keep going. So here, for example, like as opposed to doing a line plot, so MPG. Do we have MPG here? Oh, hey Krishna, how's it going? Nice to see you in chat. I mean, let's do empty cars again, right? So we're gonna say Ggplot and then empty cars, and then our x is gonna be uh I don't know, let's say this sprite. What did I miss? So I have, oh, okay, I'm missing one parenthesis. See, it's like almost Lispy, right? Like you're creating this like this data structure. DSP is not defined. I think it was called this sprite. Yeah, this. All right. So in this case, because it's not like a straight timeline, you see how like it's sort of curved over. So showing you all of the examples. But like what I like about this, like check this out, right? So if you say something like, I don't know, alpha 0.1, what we get then? Still the same because there's no colors, right? And then so we're gonna say in AES that, for example, we want to have color. So let's say color is equal to name. What happens now? Maybe gears actually. A gear. And then we fill with what? Let's say we fill. Okay, fill with carb. Yeah, very weird. This is not working. Anyway, so like if you look at this example here, you're saying, okay, well, I want to plot, you know, three density plots for each of the DRVs, and then I want to make sure that the color. Oh, because it's the same. I see. Huh? So what is Grammar of Graphics originally? Yes. So Grammar of Graphics is referencing this original book, and then the library that it's based off of is like Ggplot is the main library that inspired this. So originally it's an R library, but here I'm showing you like a oops. But here I'm showing you like an R library for it. Sorry, Python library for it. Put this back here. All right. So similarly here, like we saw these examples already, like with the intercepts, they're fairly trivial to add. And then each intercept can have like a color, a style, etc. So here, for example, this is also interesting. So check this out. So let's see, where are they even getting these data sets from? Okay, let's do this. Like the economy, right? Okay. Median duration of unemployment, I see. Okay, this is kind of cool, right? So it's just like a line, and then you're plotting x and y with like already you can sort of notice this is a lot shorter than the Matplotlib code where you would need to say like okay an axis and you say plot.show and all of that nonsense. But here it just sort of works. Uh, but here like check this out. So if you say for example a geometric line that you want to add an arrow, it's like, well, it just adds the arrow here, for example, right? Like at the very end of it, which is kind of cool. And so let's see what other stuff we can add here. All right, so it can take in a mapping. Where is it? Okay, so all this is stuff we expect, right? Like the color, uh, the thickness and stuff. I don't see arrow anywhere here, so that's kind of interesting. I wonder if it's defined somewhere else. We'll check it out. Um, but yeah, like this is straight up saying, well, you could, have an arrow on both ends. And so it's like very, again, very compositional in nature. Okay, make it dashed to give it a color of pink. Make it super thick so it looks almost watercolored. But this is sort of also where it gets kind of interesting, right? So let's say you gave it a bunch of like geographic data, for example. So this is how you can get to the point where you're doing like these sort of like Edward Tufte level visualizations. So you have all of these things, right? Like continents, islands, rivers, political boundaries, walls, roads, locations. Okay, so it looks like we're in the land of Westeros. You have some geometry, etc. So all of these is like just like your pre-processing. And then in this map here, well, you're saying, okay, I want to do a geo map with Westeros and fill it with none. And then I want to do a map of the islands, fill it with nothing. And then I want to do the political map and fill it by claimed by. Then I want to do a wall and put a line string. When I put a lake, I want to give it a watercolor. And so here, like, This is cool, right? So like then when you say where is watercolor defined? Yeah, so watercolor you can see here is just like a hex value. And so for wall color it's like white, and then road color is just brown. So then you're like, okay, great. I drew a line string, I drew a map. And then when it comes to the actual text, you're saying, okay, well, I want to add some text to political. And then I want to make sure that it's using the centroid of. So I want to put it at the very center of the thing that I'm labeling, uh, the country that I'm labeling, and I want to label it by claimed by. I want to give it a size of 8, and I want to make sure it has a bold font. Same for the text. Like for each city, I want to at the very center of a city give it its name. I want to make sure that my labels are Westeros. I don't know what this brewer is doing, and then scale it, and then don't give it a theme, and then just do this, right? So then you kind of end up with something kind of ridiculous when you think about it, right? Like you would imagine that this is typically something that you would have to draw by hand to do, but uh, I think the fact that you can just use grammar of graphics for this for me is extremely compelling. And the reason I'm giving this tutorial is because I want to start using this extensively for all of my machine learning plots. So this is sort of similar, I think, to what we saw, but as opposed to just having like, let's say, a hard-coded scale, you could have a continuous scale. So this is what's sort of interesting here. Uh, I should mention, by the way, like if you go to the API, right, and we go to, I believe, here. So if you just scan, so can you also make interactive plots like D3? Yes, actually, there is the final example here is interactive. So I'll just like make sure to quickly show it. But sort of this gives you a sense of like these are all the different kinds of geometries that you can support, and for each of these geometries, these are the kinds of statistics that you can support on it. This is the different ways that you can facet something, the different ways you can scale something. And so then it's just a question of composing all of these like one after the other to get the kind of behavior you want. But I often think that looking at the example gives you nice inspiration. Uh, Here, where was this? All right, so this is interesting because there's sort of a lot of data pre-processing happening here. So let's just get back to this example because it looks a bit hairy. Uh, this is, I think, here, just use something called a step plot, right? Instead of a regular line plot, you do a step plot, and then you just give it the same data that you've always been giving it. And then, at this point, you know how to do this, right? Which is, you give it another step plot. Maybe you see, like you make it a bit thicker, give it a different color. So then none of this is surprising at this point. Um, so I think here there's these guys, geometry V line. I don't think it's very interesting either. We already covered this. So I just want to show you quickly the really crazy examples, and then I want to show you the animated example as well, because it's important. So here, for example, this is a spiral animation example. And so the way they make this work here is you can see like they have this sort of generator for the animation where they plot the thing, and then they vary the parameters of the animation, and then they feed this plot to a pipeline animation and then just repeat it and then save it to an MP4. So this is sort of like the paradigm. The Ggplot itself, as you can imagine, this is what draws the state of the thing at one point in time. And then this is basically how you want the animation to change. So you asked about D3. Actually, I think there was an example. Interactive, where was it? Oh, okay, sorry, never mind. So no, there isn't an example here like D3, but there's another library called Ggpie that does. So this is a more robust library actually, and it does have these interactive animations. However, the project is dead. Like not no one's contributed to it for like the past like 2 years now. I mean, you can see wow, longer, like 5 years. Uh, and so it's broken actually right now. So if you try to install it, you need to make sure that you install like an older version of NumPy and Pandas for this to work. It's sort of a mess. I was thinking of fixing it myself, but then just got busy. Um, so the example, like I thought was kind of ridiculous, like that made me feel like, okay, well, this stuff is kind of crazy. Was this one? So here. they actually draw, like, just so we know that what we're drawing, like we draw a periodic table with Python, which I thought was kind of nuts, right? So let's just go over like how this could work, because this is, you know, kind of gorgeous, I think, at this point. So let's go over it. So first things first is we're fed some sort of elements by CSV. So each element has its atomic number, it has its name, its electronic configuration, all of the above. So then what you do is you make sure that you group the elements. You make the bonding type a category. Uh, you make sure that the metals are a category, and then you make sure that the atomic number is actually now string instead of an integer, because you're going to plot it, right? So then the periodic animal has two tables, like top and then bottom, right? So this is what this was about here. Basically, it's just to distinguish between the top and the left, and the top and bottom elements. The next thing that you do is that you have the number of rows you have, the number of columns. And so here, like if we sort of come to the part where they're putting it together, they're saying, okay, well, it's a plot where we're taking these X and Y coordinates. I mean, yeah, and you can have this in a Jupyter notebook. Actually, like this is all here, right? Like, so this is us running, this is actually running code. I was like showing this example at the very beginning. But yeah, like the idea is I want to start using this for all my machine learning code. And I guess the use case for this has not been machine learning, it's just arbitrary data visualizations. But I just think like this sort of paradigm of thinking in terms of verbs is very powerful. And so here, for example, let's say you're taking the top and bottom, and then each of these is a tile, and then each tile has a tile width, and then each tile has a height, and then same for here. Right, so this is already getting kind of crazy, right? And you notice this is all like within this sort of XY axis, right? So the next thing that they do is they're like, okay, well, we did this part and then this part, and so what they do is that they, oh, I see. So the table is upside down, so they flip it, and so this is the scale.y.reverse, right? You're saying, okay, I do this, now I flip it. You can also like apply color to it, like where here, for example, they're doing it via the metal type. And so you say, for example, just here at the very beginning, the only change we needed to go from this to this is this line where you say fill it by the metal, and then it's gonna color it this way. Uh, so now though, we need to add some text to this, right? So we need to add a bunch of stuff. Like, look, if you look at this, there's the atomic number, there's the logo for the element, there's the name, and then at the very bottom, I think it's mass or something. I forget what the thing at the bottom is here. And so if you go here, okay, so first off, they said like, look, it's crowded, so then we just make the figure bigger. And then, you know, that's pretty much it. And so now here they're, for example, just saying, okay, we want to have the inner text, and then we want to add the inner text to the top and add the inner text to the bottom. Inner text is just a Python function, right? This is now how you can imagine how you can compose your own functions once you get this like sort of verb paradigm. And so what you need to do is return, like you need to return a bunch of layers. Your layers is going to be a list of a bunch of geometry texts. And in each of these geometry texts, what you're going to have is some data. You're going to have the label, which is the atomic number, the symbol, the name, and atomic mass, yes. And each of these are nudged in the XY coordinates so that you can put them in the right side of the visualization, and then you make the visualization big. And honestly, when I saw this, like my mind was kind of blown. Like I couldn't believe that you can just draw something like a periodic table from a pandas data frame and make it look this good. Like I had no idea this was possible. Uh, so another example I thought was interesting was this one. So where was it? The guitar fret. So because this doesn't even feel like it should be possible, right? It's not even like a mathematical visualization. It's like, well, you have this thing called the guitar fret, and the way this works here is you're saying, well, we're gonna create this frets object, and then there's 23 frets, and then uh, okay, I don't know what this inverse and breaks is doing quite yet. Major breaks, and then you have these minor breaks. Okay, I guess it's just like some way of creating the data frame for yourself. So once you have this data frame, you can say, well, I have this fret, this string, set up all the chords that you need. then they're saying, okay, well, this is the standard. So my first thought is this is very similar to uh, DPOR. Yeah, yeah, actually it is. And I think it's sort of unfortunate that in this move from R to Python in machine learning, it's we didn't take sort of the best part about R, which was its data visualization libraries. Um, so yeah, I mean, I don't fully understand how these frets work because like I sort of forgot all my music theory, but this is to sort of give you some sense of how all this stuff works. So yeah, I mean, like I hope this was helpful. For me, the most instructive example I think was this one, like the periodic table. Everything else sort of like builds on this idea, but for me, this was sort of this is insane, like straight up. Uh, and yeah, I mean, I hope this was helpful. I think stick around. Like I may in I think like about 30 minutes or an hour. Uh, Actually, maybe a bit longer, but definitely today. I'm going to be doing a stream on using graph convolutional networks and graph isomorphism networks in GNNs. So I hope this was helpful. And if you have any questions or suggestions for other topics, like feel free to let me know. And thank you so much, everyone.